Hi Addie, today we are doing lesson number 12, and lesson number 12, you can see Danny's foot back there. Lesson number 12 goes over place value through the trillions. So that is going to be super important for you to know your numbers and their place values all the way to trillions. Why? Because sometimes we spend trillions of dollars, and you should probably know how much money that is. As a country, I mean, not as an individual. Okay, so we'll go over that. That is going to be super fun today, and I think you're really going to like it. First, we're going to start out with multiplication facts. You have 64 of them that you're going to do for 5 minutes, and I'll see you when you're all done. Okay, bye. Okay, hello again, Addy. You should be done with your facts practice now, your 64 multiplication facts. Good job on that. And now we're going to do the rest of mental math, okay? And so the first part of mental math is to count by 1/4 all the way from 1/4 to 12, okay? So we're right here. We're going to go start at 1/4, count all the way to 12. Ready? And go. 1/4, 1/2, 1. You can help me, Danny, if you want. 1 1/4, 1 1/2. Oh wait, I skipped one. Oh, I totally messed up on that. Did you hear me mess up? Oh, I hope you heard me mess up and you were like, wait, Mom, you totally messed up on that because which one did I forget? If you were listening, I forgot this one, 3/4. When you count by quarters, you also get 3/4. So let's try it again. Let's start over. 1/4, 1/2, 3/4, 1. 1 1/4, 1 1/2, 1 3/4, 2. 2 1/4, 2 1/2, 2 3/4, 3. 3 1/4, 3 1/2, 3 3/4, 4. 4 1/4, 4 1/2, 4 3/4, 5. 5 1/4, 5 1/2, 5 3/4, 6. 6 1/4, 6 1/2, 6 3/4, 7. Okay, you keep going all the way to 12, okay? 7 1/4, 7 1/2, 7 3/4, 8.
9 1/2.
Shh. Don't mess her up.
Okay. Sorry.
That's okay. Okay, I think I made it to 12 in my head. So if you didn't quite make it there, you can pause it. And then it doesn't say to count backwards this time, so we won't have to do that today. Let's go on to the rest of mental math. And remember, these are the ones that you kind of do in your head, alrighty? So we are going to start with A, 6 times 40. So write that down. What I would do if I was doing that in my head is I would just do, well, what's 6 times 4? I know 6 times 4 is 24, and then I would add that 0 from the 40. So that's what I would do. That's just to give you a little hint of how to do it in your head. Okay, let's go on to B. I won't give you any more hints because I think you know how to do it. B is 6 times 400. Okay, write that down. Let's go on to C. C is $12.50 plus $5. Okay, D is 451 plus 24. Let's go on to E. E is 7,500 minus 5,000. And F is $10 minus $2.50. Write down that answer. Okay, now with G, this is one where I think it might be easier if you close your eyes. And I'm going to go through this exercise and then you write down the final answer, but you should be able to do it in your head. So just close your eyes and we're going to start with the number 12. Divide by 2. Subtract 2. Divide by 2. Then subtract 2. What is the answer? I'm going to say that one more time just so you can be sure that you get the right answer, okay? Start with 12. Divide by 2. Subtract 2. Divide by 2. Then subtract 2. Okay, write down your answer. Now this one, I think you're going to have to pause the video for a little bit and figure this one out because it is a little bit tricky, okay? So this one is problem solving, and it tells you that a dot cube, I don't know why it doesn't just call it a dice, it's a dice, right? So a dot cube like this one has 6 faces. So we can only see 3 of them in this picture, but as you know, there are three more that we can't see. So a dot cube has 6 faces, or 6 different surfaces. The faces are marked with dots, right? And there's either going to be 1, 2, 3, 4, 5, or 6 dots. And then it says all together, how many dots are on a dot cube? So how many of these individual dots, like these that I'm circling, are on a dot cube? So I'm not going to give you any hints on this one. You try and figure it out and maybe show your work, because I'm interested to see how you figure it out. Okay, pause it, and when you are done figuring that out, we're going to move on to talk about this concept of place value all the way to trillions. And in our number system, the value of a digit, like let's say the value of 5 right here, I wrote a little 5 on top, depends upon its position. So of course, like if you put a 5, let's look down here, if you put a 5 here, that has a very different value than if you put a 5 here, right? Because there might be like a bunch of zeros after that. And these 5s, even though it's the same digit, it has a very different value because one is in the ones place right there, and one is in the millions place right there, right? I'd rather have $5 million than 5 $1 bills, wouldn't you? Yes. So those are very different things, and we're gonna go over how you figure out the value of the different digits when they're in different places, right? So this is a chart to kind of break down the whole number place values. And it's supposed to help us figure out the value. And in the pinks, what it's going to be basically is if it's in pink or all the way to the right, this is the ones. So if you have something right here, it's in the ones place. And then right here, it's gonna be like 10 ones. And right here, it's gonna be like 100 ones, okay? So if you have something here, that's just like 100 $1 bills. Okay, hopefully that makes sense. Now let's look at the next. What if you move to the left and you're in this green area? Well, if you go to the green area, then you're not in the ones anymore, you're in the thousands. But it follows the same pattern. So if you're right here, if you have a number here, that would be like 1,000. Or if this number is 4, it would be like 4,000s, okay? If you are in this middle position in the thousands, then you're in the 10,000 position. So if you have a 1 here, it's the same as saying 10,000s. Okay, hopefully that makes sense, but I think it will as we do more examples. And then right here in that third position over is the 100,000. So again, if you have a number here, that's going to be 100,000. Okay? Okay, so hopefully that makes sense. And let's move on. What if you're further over to the left, and now the digits are getting more and more value, like by a lot, right? So you move from ones to thousands to now millions. So the yellow is in the millions position. And it follows the same pattern, of course. So if you have a 1 here, that's going to be 1 million. If you have a 1 here, that's going to be 10 million. And if you have a 1 in this position, it's going to be 100 million. Okay, let's keep moving over to the left. Now we're in the billions. Now we're getting pretty big. I mean, because, this is so important for you to know, because when you hear on the news that we are spending billions of dollars, I want you to appreciate how huge that number is. This is in the 1 billions position, so just billions. This is in the 10 billions position, and this is in the 100 billions position. So if you have like a 3 here, that would be 300 billion. Okay, let's move over to the left again. Let's use black, I guess. Okay, so this is in the trillions position. Okay, so same pattern. This is 1 trillion, 10 trillion, 100 trillion. And that's as high as we're gonna go for this lesson, but that is plenty high, okay? That's a really, really high number. So let's do some examples and see if we can figure all of this out, okay? So example 1, in the number, and I'll just say the digits within this number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 0, 0. And the question is, what number is in the 10 millions place? Okay, so let's try and break that down. If we look back at this, we can see that these first 3 numbers right here are in the ones position, okay? And then let's look back again. The next one is going to be these group of 3 numbers, and these are in the thousand position. But it's not asking about thousands, it's asking about the millions place, right? But if you look back at here, you can see that millions comes next. It's the next one over in this yellowish color. So these are in the millions position. And just for fun, I'll tell you that the next one is in the billions position, even though it didn't ask us that. Billions. Okay, so it wants to know what number is in the 10 millions place. And remember the pattern that it follows, okay? So when we're looking at the millions place, this 6 is going to be in the ones position, like 1 million. This 5 is going to be in the tens, like 10 million. And this 4 is going to be in the hundreds, like 100 million. So the one that's in the 10 millions place is this. So it says, what number is in the 10 millions place? And the answer is 5. Final answer, okay? All right, and see, this kitty is so shocked because that number is so huge. I love it. This guy's shocked too. What's his name? I don't remember his name. Do you remember, Danny?
I don't know, but he's the guy who said, Flynn in the fur.
Yeah, that's right.
Flynn.
From Cloudy with a Chance of Meatballs. Wait, is his name Flynn?
Fur. Flint. Yeah, Flint Lockwood.
Flint Lockwood. Okay, we got it.
Like I remember it because the police always says, Flint Lockwood.
Yeah, that's pretty funny. Okay, so example 2. Example 2 says, in the number, and I'll just say the number this time, 5,764,283. And notice how I said that number? That's the proper way to say it because I didn't say the word and at all. Did you notice that? 5,764,283. It wants to know what is the place value of 4. So we have to look at the number 4, and that you can see I've highlighted it. It's right there. And it wants to know what's the place value. So if you forget, you can kind of look back at the diagram, but I'll just kind of remind you that this group of 3 is in the ones place, and then this group right here is in the thousands place. Thousands. And then look within the thousands, there's a ones place, a tens place, and a hundreds place. So I would say for example number 2, that the place value is the thousands, or you could, if you wanted to be a little bit more precise, in the 1,000s place. So the 1,000s place is my final answer, okay? Then the lesson talks about, you know, sometimes large numbers. So if somebody writes a large number like this, that is really hard to read if there's no commas in it. So large numbers are easier to read and to write if you use commas to group the digits. And so if you have a number like this and you want to place commas that are not there, what you do is you begin at the right, so begin at this end of the number, and you move to the left and you write a comma after every 3 digits. Okay, so we'll start here. We'll go 1, 2, 3. and I'm gonna put a comma right here, okay? And then again, we're gonna go 1, 2, 3, and I'm gonna put a comma right here, okay? And then we're gonna go 1, 2, 3, and I'm gonna put the last comma right here. So then it's easier to read that number. Hopefully I did that right. I'm kind of looking at it and yeah. So then you can see that this number, if we wanted to say it, let's see, is this the right number? Okay, no. If we wanted to say it, oh, another thing. If you wanted to say it, here's the thing that makes it easier. So you have a big number like this, and you have all these commas. This is kind of like what I just wrote. This first comma separates the ones from the thousands place. So right here, I'm gonna write 1,000 for this comma, because it comes right after this area that is the thousands place. Okay, and then this comma, the next one over, is like separating the millions from the thousands place, but it comes right after the millions place because the millions place is here. And so I'm gonna put millions pointing to that comma. Okay, the next comma is going to be billion, comes right after the billions, and the next comma is gonna be trillion, because it comes right after the trillion. I'm gonna erase the S on these. Okay, and this is what helps you read the number, because what you do is you say these numbers right here, like maybe it's 1, 2, 3, and if 1, 2, 3 is written there, then you're gonna say 123 trillion, because this comma, when this comma comes up, you say trillion. Okay, and then you say the numbers that are come here, and maybe it's gonna be like 345 billion, because when you get to this comma, then you say billion. When you get to this comma, then you say million, and when you get to this comma, then you say thousand. So let's look at this number that we had that's really long. This one is thousand. This comma is million. This comma is billion. So now it's much easier to say that number. You would say, and I'll show you a highlighter as I go along, okay? So you would say 1,234,567,890. Okay, so that made it a lot easier, because when these commas come up, you say the word that goes with that comma. So you can remember it that way if that makes it easier for you, or you can just do it your own way. And if you have questions about it, you can ask me, okay? Let's do example 3. And it says, use words to write the number 1024305. So the first thing that we're gonna do is insert commas to make it easier. Okay, so let's put in some commas. I'm gonna start on this side and count over 1, 2, 3, put a comma here. Then I'm gonna count 1, 2, 3, put a comma here. So then this comma is the one that is 1,000, and this comma is the one that comes after that that says million. So the way I would read this is 1,024,305. So if they want us to write it out in words, what we would do is we would say 1,024, and you hyphenate that one because anything from basically 21 to 99 is a compound word, and you're gonna hyphenate it. 1,024,000 305. No ands. Okay, so that is the final answer. Okay, alrighty, let's go on to example 4. Example 4 says, use digits to write the number 1,250,000,000,000. Whew, this is getting tricky, isn't it? So the number again is 1,250,000,000,000. So I sketched out the pattern first because, you know, the lesson plan says sometimes when you're writing humongous numbers like this, it's helpful to sketch out the pattern first. So this is the pattern, and I already labeled the commas and the words that go with them, okay? So we're gonna start with 1 trillion. If we were to put the 1 in the 1 trillion's place, right, then the trillions place are going to be right here in this area, okay? And 1 trillion would be, let's do this, 1 trillion. Because it's in the ones place in the trillions category, okay? So then let's move on to the billions. And the number that goes in the billions is 250 billion. So the billions place is here because the comma where you say billions comes right after that. And the number that goes there is 250. Okay, and that's basically the whole number, but the only thing we need to do is add all of these zeros. You can see how hard this would be if you haven't put the pattern out, because 250 billion, like how many zeros goes in that? You know, you would have to figure that out. So this is a little bit easier way. And then when we read it from left to right, you can see that we are going to say, let me erase this so that you can see me reading it. I'm gonna say 1,250,000,000,000. And then that's all you say because all of these numbers are zeros. Okay, so that's how you do that one. Let's move on to where it says multi-step problems. I put that little GIF there because the dog is going down all those multi-steps. Get it? So cute, huh? You can ride a skateboard. A dog that can ride a skateboard. That's crazy. Okay, so multi-step problems, it's going to remind us first about the operations of arithmetic, which is addition, subtraction, multiplication, and division. These are all the different operations of arithmetic. And in this table right here, it tells you, it just reminds you of some of the vocabulary words, right? So for example, sum, a sum is the answer that you get when you add. Okay, and then it reminds us that difference, when you hear that word, it means the answer that you get when you subtract. Okay, so I think you remember these. It's just, this is a little reminder. The product, so the product of 3 and 3 would be the answer that you get when you multiply. So in that example I just gave, the product of 3 and 3 would be 9. Because that's the answer that you get when you multiply. Okay, and then let's do purple. The quotient is the answer you get when you divide. So if I were asking, well, what's the quotient of 8 and 4, then the quotient would be 2, because that's the answer that you get when you divide those numbers. Okay, let's do example 5 and maybe it'll be a little bit more clear. Example 5 says, what is the difference between the product of 6 and 4 and the sum of 6 and 4? So what the heck are they asking in this question? It's a little bit complicated, but you are seeing some of those vocabulary words that we just looked over, right? Because you're seeing the word difference and you're seeing the word product and you're seeing the word sum. So those are going to be important, okay? And so the first thing that we're going to do to make this a little bit simple is underline some of these operations, right? And the operations, by that I mean like these arithmetic operations. So what is the difference between the product of 6 and 4? I'm going to underline that. And then I'm going to underline the sum of 6 and 4. Okay? So let's put numbers to those parts that I underlined. So if you look at the purple part that I underlined, which is the product of 6 and 4, that's going to be equal to, product means multiplication, so it's going to be 6 times 4. So we're going to get 24. So 24 is the product of 6 and 4, and you could just plug that into the question there. Now let's look at the green that I underlined. The green part of what I underlined is the sum of 6 and 4. And so what that means is sum means the number that you get when you add. So we're going to have 6 plus 4, which is equal to 10. And you can basically plug 10 into that part of the question. And then if you write the question again, if I wrote that whole thing again, it would be, what is the difference? What is the difference? Sorry, my handwriting is bad right now because I have this iPad kind of standing up. Okay, what is the difference between the product of 6 and 4? So instead of writing the product of 6 and 4, I'm going to do this purple part and just put the number 24 and plug it in. What is the difference between 24 and instead of the sum of 6 and 4, I'm going to do the green part, which I figured out the sum of 6 and 4 is 10. And that's the question kind of rewritten. And then we have to look at this. So the question is, what is the difference between 24 and 10? And remember that difference means the number that you get when you subtract. So all they're asking for here is basically, what is 24 minus 10? Okay, and you can figure that out, and it's 14. So it's saying, what is the difference between 24 and 10? The difference is the answer to that subtraction problem. And the answer is 14. That's the final answer. Okay, that's the whole lesson, Addy. Thanks so much for paying attention. I hope you followed along and it was kind of fun for you, okay? I'll see you in a minute. Okay, Addy, I hope you liked that lesson today. And now it's time for you to do your practice. So you are going to start right here with the lesson practice at the bottom of the page. And if you need more space, I'm going to give you an extra sheet of paper so you can show your work, okay? And then you have a problem set. It's a little bit long because it's all of this page and all of the back page. And you can tell that some of this is going to be your review. So good luck on your homework, and I can't wait to correct it and see what you do. Okay, love you, Addy. Bye.